right, robot project. Today is a nice low brain power day. You don't have to do much thinking. You just have to listen to me introduce the robot project. I realized that it made more sense to do this today, and then we will circle back to the Tinkercad stuff on Wednesday, unless we get through this really fast and you guys don't have any questions, but in my experience, this usually kind of takes a while to walk through. So, recap, maybe a reminder for people who added the class late and weren't here on day one. This class ends in a robot tournament where we are going to go over the rules in more detail today, but there are these little colored arenas and the robots are competing to accomplish some task to move around or gather these little cubes that are scattered across the board. This is not BattleBots. Okay, the goal is not to destroy the other robot. We need to reuse all of the equipment next year. Okay, so no chemical, biological, or nuclear weapons, dangerous projectiles, acids, other things that could destroy the Arduino or other stuff such that the lab staff cannot disassemble it and reuse it next year. I'm not involved directly, but Cornell does have a combat robotics club. Is anybody in here in that or involved with it? Okay, so there's your guy. If you are interested in destroying other robots in a more violent manner, you have an outlet for that, but it is not this class. Okay. Again, this is something people usually have a lot of fun with. I showed these slides on the first day. Dave Partino gets really excited about it. People dress up in costumes. We had a Hungry Hippos team one year. I don't know if this student is excited because that's a good thing or like a robot just lost, who knows, but it's a fun day, okay? Disclaimer, these slides are an overview. There is a massive, or there will be, a giant rules document on Canvas. It is not published yet because I still need to tweak and finalize a few things. So again, this is an overview. All of the official rules are on Canvas. In the event that there is a discrepancy or I need to update something, Canvas is the authority, okay, not these slides. So these lecture slides will be posted with everything else, but when you need to go look up the competition rules, you go to the robot rules page on Canvas, not this PDF, okay? I mentioned this way back at the beginning of the semester. Last year, actually I didn't make a slide for this, but the first year we did this competition, robots started on opposite sides of the board. The goal was just to push as many cubes as possible to the other side of the board at the end of a 1-minute match. One team figured out that they could just build a really heavy robot, drive forward a foot and stop, because all you needed to do to win was move more than half of the cubes across. You did not need to move all the cubes. Okay, so the next year we switched things up and said you had to bring the cubes back to your side to make things a little more challenging. We have done that, I don't remember, 3, 4, 5 times now. This year we decided to switch things up again. So I had a bunch of text here. I hate standing here and reading bullet points with some of the details. It's a 1-minute match. There was kind of an infinite plane extending across the board here. So if cubes got knocked off the board, we would still count which side wherever they're on, kind of as a tiebreaker. Robots were allowed to pick the cubes up. They didn't have to be touching the board. So again, all these details for this year will be on Canvas. The goal this year is for the robot to gather the cubes. Okay, so it does not matter which side of the board they wind up on. Your goal is to gather more cubes than your opponent does. Most of the other rules remain unchanged. It's still a 1-minute match. The goal is to gather as many cubes as possible. Whoever has the most cubes within the perimeter of their robot at the end wins. I'll talk more about what that means in a minute. You do not have to pick up the cubes, so it's okay if the cubes are still resting on the board as long as they are still gathered by your robot, but you can pick them up if you want to, okay? So, what counts as gathering a cube? Because I realize this could be sort of nebulous, or there could be a loophole here. The definition I am deciding on is that the cube must be completely inside the robot's outer perimeter. Okay, so if you imagine my PowerPoint drawing here is kind of, this is the main chassis of the robot, and then there's some sort of mechanism or box extended around the robot so it can drive around kind of like a street sweeper and gather the cubes. Any cubes that end the match completely within inside that perimeter, which does not have to be a physical structure, right? So if I have 2 walls like this, I'm kind of drawing a connecting line to enclose that perimeter. Anything physically inside there at the end of the match counts. If it's not completely in, it doesn't count. And this needs to be a meaningful mechanical or structural perimeter, okay? You cannot just put an umbrella on top of your robot and drive around and say, okay, all the cubes that are under this umbrella are technically within the perimeter, okay? So There's always a bit of a balance each year between people trying to find or exploit loopholes in the rules and being clever versus like, okay, we really didn't think of that one, that's just cheating. So the umbrella one is the major one I thought of. We kind of reserve the right, or I reserve the right to tweak the rules if we discover any major loopholes, since this is the first year we're trying this. You do give a design pitch about your robot to the TAs kind of early in the process, so it's not like you'll show up on competition day and we'll say, oh no, that's banned, that's not allowed. You pitch the idea early, and if there's something outlandish somebody comes up with that's rule violating, then we'll kind of tell you, no, you can't do that. But I'm hoping this covers kind of most of this scenario. Again, the spirit of the competition or the intent is to physically gather the cubes. Again, you don't have to literally pick them up, but any attempts to like totally violate that and come up with some crazy loophole here for what counts as a perimeter or meaningful structure or mechanical will probably kind of be disallowed. Okay. The tournament itself, this used to be a double elimination tournament, but that meant that some teams just went 2 and out at the beginning and then kind of had to sit there for the rest of the day. That wasn't very much fun. So we switched to a 2-phase tournament. The initial phase is round robin style, so groups of roughly 5 or 6 teams will each play every other team in that group, so that way every team gets at least 4 or 6 matches. In theory, you could still just lose all of those, but at least you got to have more matches before just going 2 and out. The winners of the round robin group then advance to a single elimination bracket. Okay, so we kind of have Robot March Madness with the remaining 8 or 16 teams. I forget exactly how it works out. The winners of those brackets, sorry, the winner of the single elimination bracket, ASML, brings a robot to the competition, so you face off against them. The TAs usually build a robot with varying levels of seriousness every year, so how I need to figure out exactly. Sometimes the second place team from the student bracket goes up against the TAs. Apparently last year, anybody who wanted to could challenge the TAs to a grudge match, so I don't know, if you're still mad at somebody for taking up points on a pre-lab on lab 1 or something, there's your chance for revenge. Okay. And then we usually have some cleanup time at the end, so again, if you want to have an unofficial rematch against another team as we're cleaning up and one of the other boards is still out, you're still welcome to do that. Okay, and again, rather than standing here just blasting through 45 minutes of rules and logistics stuff, I want to pause for questions periodically, so any questions on kind of the intent of the competition or the tournament format? Nothing? That's all super clear? Okay. All right. The robot itself, okay, so you may have noticed the plastic bins on the shelves in labs, so we're going to be transitioning from your individual kits, which had, the Arduino and multimeter and all that stuff in them, to a kit that includes basically all of the parts to build a basic working robot. So there's a chassis, an Arduino, 2 motors and wheels, the H bridges, so everything you need to build a little Roomba-style robot that can drive around using 2 motors and 2 wheels. Okay? Pretty much everything beyond that is up to you. So every team gets a $40 budget for additional parts and fabrication. So again, all the details for what you can and can't do or can't order will be on Canvas, but off the top of my head, roughly, I think you can do sheet metal fab in the machine shop, but no CNC or lathe. And you can do laser cut acrylic in the RPL, but no 3D printing. I need to double check. I know, I'll talk more about this later. To keep things fair for all teams, equal access to resources, there's no use of personal 3D printers or anything like that. Okay, same resources for every team. So again, I need to double check with Dave Hartino about exactly what facilities will be available, but that kind of starts to give you a general idea. And if you want to save money because you want to spend your budget on something else, we got plenty of duct tape and cardboard robots in the past. These things, again, it's not BattleBots, but they are crashing into each other a lot, so cardboard may not hold up as well as acrylic over 6 matches, but that is an engineering design decision, right? There is no single right answer to this problem. You have a limited budget, you have a selection of available materials to choose from. There's no best way to do it, okay? That is going to be up to you. In addition to fabrication, And you can also spend this budget on electronics. So if you want additional motors, additional sensors for something, that budget can also go to that. There are vendors and dates for ordering all of those parts will be on Canvas. Basically what we do is roughly, there's about a month we have to work on this after spring break. So working back from the competition date and shipping times for the vendors, there will be dates at which the lab staff will place a bulk order for all students. So this $40 doesn't include shipping because we're just ordering it for the whole class all at once. But you can order stuff from McMaster or DigiKey and maybe a couple smaller electronics or hobbyist robotics vendors mixed in there. I still need to sort that out with Dave. So yeah, giving you a ballpark idea of kind of the magnitude of the project, and you can kind of tell from looking at the pictures back at the beginning, right? This is not a large, expensive $100 or $1,000 robot. Like this is enough money to, laser cut some acrylic and buy a couple extra servos or something, but it's not like a large, very complex thing just because of the scale of the class and the time we have to do the project. Okay. Let's catch up to where it was. Okay. Again, not BattleBots. There will be a list of prohibited things on Canvas. One of the key parts here, there are some dimension constraints on the robot. So the entire robot must initially fit within an 8-inch square with no height limit. So there's literally a little box in lab that they will come put around your robot, make sure it fits. After the match starts, it can deploy up to a 12-inch cylinder. So if you look at the pictures and videos from previous years, you'll see a lot of robots kind of deploy arms or some mechanism to help gather the cues. We have reduced that from 18 inches, because my experience the last few times I ran this competition was you would have 2 robots that would deploy these big arms, drive forward, get stuck, and then kind of do a jig because they were just interlocked and had their arms stuck together and just dance in circles for the rest of the match. So maybe amusing to watch, but not ideally what would want to happen to determine who's winning the match, because at that point it just kind of became a random, okay, well the robots are going in a circle like this, so when does the timer stop and which side of the board have the cues been pushed to? So decreasing the size of the robots kind of slightly decreases that chance for random collisions and the robots just spinning around. Okay, but does not eliminate it completely, that can still happen. All right. Questions on the robot requirements? Yes?
Are you allowed to repair your robot in between?
Are you allowed to repair your robot in between? Yes, if it's quick. So the match, we're kind of doing the whole tournament in a 3-hour window. If something, if a wire comes loose and you can pop it back in, if something comes off that can be hot glued or duct taped back on, yes, but like you don't have time to run back down to the RPL and laser cut something new. So, kind of bangs and bumps and things that can be quickly put back together, yes, but if something like if a piece of acrylic just totally cracks or something, then you're not going to have time to fix it. Okay? Sorry, I think I saw one hand, I forgot if I saw another hand. Any other questions on the physical robot? No? Okay. Code. So I can't tell if I have just gotten better explaining this, or if you guys are just the quietest class I've ever taught, because I feel like I usually have like 20 questions by this point in the presentation. Yes?
Can you hot glue wires into the breadboard?
Yes. So the question was, can you hot glue wires into the breadboard? Wait, let me take that back. Let me double check with Dave Hartino, because again, it depends on exactly what we need to be able to reuse next year and how much of a pain it is for the lab staff to disassemble it. We may be able to do something like a strain relief point where rather than hot gluing the individual wires into the breadboard, you bundle the wires with a zip tie and then zip tie that to the chassis there, right? So ideally, there's something anchoring the wires, but hot gluing a bunch of individual wires into the breadboard. Do me a favor and ask that on a discussion after class so I can make sure I get an answer from Dave, because I'm going to forget. Yes?
When you say that the robot needs to fit within a 12-inch cylinder, can it be a 12-inch cylinder in any orientation?
Vertical.
Okay.
So horizontal 12-inch diameter, infinite height. Okay, so the robot must fit within that initial 8-inch square, infinite height. It can be as tall as you want, although in practice, there isn't really much of an advantage to building a robot that's 2 feet tall or something, because that just makes it top heavy and it's going to fall over. And then can deploy to 12-inch cylinder, in a horizontal plane any height. Okay? Yes?
If you push the other team's robot off the platform, but the team's robot has more cubes inside of it at the end of the competition than you do, who wins?
So the question was, what happens if you go off the platform? Basically, there is no out of bounds. It is theoretically perfectly okay to just like grab all the cubes and leave. Like if you want to program, if you just say, we don't want to detect the border at all, we're just going to grab as many cubes as we can and run away, you could do that. Okay, so there, again, I'm not going to cycle back through 10 slides, but in past years, the rule has been that the dividing line between yellow and blue extends off the board. So they would, for the initial score, cubes on the board would count, and then for a tiebreaker, if they needed to count cubes off the board, would count. So this year, it's basically, you know, the border is still there because the boards are a couple inches high, right? So if you drive off the board at the beginning, your odds of getting back on the board are very low. So it's probably still a good idea to detect the border and avoid driving off the board. But the winner is determined by whichever robot has the most cubes regardless of location. So you can be on either side of the board or off the board. And I think the rules say that, but I will need to double check to make sure that language is clear. Okay? Yes?
If you make a super heavy robot and you hug the other opponent, but while you're hugging the other opponent, you also have some cubes within your range. Well,
So the question was if you make a super heavy robot and hug the other robot, but also, so it depends on exactly where the cubes are. If the cubes are within both robots, then they don't count, right? It only counts if the cube is uniquely within your perimeter. So if we do a Venn diagram of the two robots, right? So only the cubes that are only in your robot count. But given these size constraints, I think it would be hard to build a robot that could completely encompass another robot and stay within that 12-inch cylinder. Okay, unless, I mean, if the other robot only stays within the initial 8-inch square and doesn't grow in size at all, then maybe you could do that somehow. The other thing to consider there is that if you want to add weight to your robot, that counts as part of your budget, right? So any heavy, if you want to get, you know, a hunk of steel from McMaster or something, or whatever, or the densest, cheapest material you can find is, that does come out of part of your budget. So. I was just about to bring up rocks. There's always a question every year about what about scavenged materials or things you had laying around. So again, to keep things even, you know, if you happen to have your own personal shelf of like metal bar stock in your room for whatever reason, like it will be evaluated at the same cost it would be to purchase that item new. So that prevents like, oh, I just happen to have, you know, I do this as a hobby and I just had 12 servos laying around anyway, so those are free. Okay, we need to keep it fair for students who don't have, same as like you can't use your own 3D printer. So that gets a little weird with things like rocks, where like, hey, I wanted to wait on my robot and I found a rock on the ground, where we will address them on a case-by-case basis, but you can go to like a hardware store or a gardening center and look at how much would it cost to buy a bag of rocks, right? And we can figure out, okay, based on the weight of this one rock, how much would this rock cost? And I think probably pretty cheap, right? Like I can go down to Home Depot and buy a bag of gravel for a few bucks or whatever, right? So a fist-sized rock is probably, I don't know, like a quarter. I'm just making, you know, ballparking the numbers there, you get the idea. But no materials are literally free. We will either evaluate the new purchase cost or kind of find the equivalent purchase cost of whatever the material is. Okay? Yes?
Are things that come in like large quantities, like I don't know, glue or like stuff like that, is that evaluated by the volume that you use for price, or like by the total container? Like,
so the question was, are things that come in large quantities evaluated by the volume you use or the total container? The total price, but you can split things with other teams. So this is, I think, less relevant. So, but there were also, I need to double check with Dave. Some things like duct tape might be available for free in reasonable quantities in a lab, right? So if you're going to try and, if you need 2 pieces of duct tape to hold something on, that's one thing. If you are going to try and steal an entire roll of duct tape to build your robot's entire structure out of duct tape for free, then we would say like okay, no, that's circumventing the rules. This was, I think in 2021, again, I need to check with Dave, a little more relevant when we did, had Amazon as a vendor, and some things like Amazon only sells a 12-pack, but we could say, okay, you can split the cost of that if you could, like, you know, here's a 4-pack of servos, and we found 3 teams that also want servos, so we're just gonna order this and split it. For things like, again, I need to check with Dave for kind of fastener materials. There's a list of, I didn't have the complete list on here, screws and certain things that come in your kit and are kind of considered free, and then beyond that, I'll need to check with Dave about tape and glue and everything. When it comes to more like sensors and parts and things that might be bought in a pack, you do have to pay for everything even if you don't use it, but if you can find another team you can split it with, then you can divide the cost. Okay? Rob first and then here. Yes. Yeah.
You say split. Can you, if you buy a pack of something entirely for your team, can you then sell to other teams at a slight upcharge?
No. Clever, but no. Okay, there was another question next to it.
Are we allowed to 3D print RPL?
I need to double check with Dave, but I think it is only laser cutting and not 3D printing. Okay, that is not up to me, that is up to the lab staff and kind of the volume of stuff they can handle given the size of this class. And laser cutting is a lot faster than 3D printing for the most part. So last time I taught, the answer to that question was no. I don't know if the RPL has more 3D printers or something now. But for now, count on it being no, but I will have an answer for you by the time the project starts. Okay, way in the back there.
Yeah, can we get like a drawing or like dimension of like what the cube that we're picking up actually is?
They are 1-inch wooden cubes. And again, this is, if it's not in the slides today, more details like that will be on the Canvas page. Okay. Same thing for the robot chassis itself. It's kind of these 3 little milled fiberglass boards that have tons of mounting holes and stuff on them. I need to check with Dave Martino, but we probably have CAD files for those boards available. So if you're thinking about where you're going to mount stuff to them. Yeah, we like opened the floodgates here. You guys were dead silent now, which is great, right? Like I had to like prod you guys to get you to start asking questions. So keep them coming. Over here.
Are we allowed to open sides on the robot, or do we need something physical to define the
Are you allowed to have open sides to the robot, or do you need something physical? So you are allowed, again, this is the first time I've run the competition like this, so if I had, for example, holes here or something, so like, you know, I could gather cubes from multiple directions, that is good. The sides do not need to be solid, okay, but it does need to, this is somewhat nebulous, say, kind of have meaningful mechanical or structural use. Again, with the idea, what I don't want you to do is just literally put a 12-inch diameter circle on top of your robot, like an umbrella, and then, you know, pretend this camera's a cube, say, oh, my circle's above the cube, so that cube is within the perimeter, right? If you have fingers or some gathering mechanism, right, that kind of defines the perimeter that could reasonably actually help gather the cubes as opposed to just cover them, then that is okay. Does that make sense? Okay. Yes?
Like a follow-up question, is there an explicit height of where the perimeter is defined?
Explicit height of where the perimeter is defined?
Yeah, I guess, like, you said there's an umbrella limit, or like
And it has to be something that actually is involved in gathering the cubes or keeping the cubes, right? So if it's just the umbrella, then that isn't actually helping gather the cubes at all, right? It's just driving over them. So I guess given that the cubes are 1 inch high and they're going to be starting resting on the board, that kind of gives you an idea like, okay, well, it's going to need to be pretty close to the board to actually help gather them. But I guess, again, I'm thinking of, say you had some mechanism on that was picking the cubes up and like lifting them, dumping them into a tray on top of the robot, then that would be okay, because that tray, if I have a 12-inch circle on top of my robot, but I'm picking the cubes up and putting them on it, then that tray is actually helping hold the cubes. So that's different from the umbrella scenario. Okay? In the back.
Is there any rule for the starting position of the robot?
You gotta talk a little louder, I can't hear you. Okay.
Is there any rule for the starting position of the robot?
Is there a rule for the starting position of the robot? Yes, we are going to get to that in the slide later. Okay. I think I saw another hand in the middle somewhere. Yes?
Are we getting Raspberry Pis or no?
No Raspberry Pi, only RGB. Okay? And there's another, and you cannot spend part of your budget on a Raspberry Pi. Okay, so there are some limitations, and I know you could get a Raspberry Pi Pico for $5 or whatever, but all of the computation and processing can only be done with the Arduino. Also, no Bluetooth modules. Okay, so you cannot buy Bluetooth and then steer your robot from your phone. The robot must be autonomous. That rule predated me, or no, I think I actually added the Bluetooth rule one year, but the Arduino only rule has been there since before Raspberry Pis existed, even. It's just to kind of keep it, even given the programming content we cover in this class and how some people might have totally different experience, that's to avoid giving one team an advantage of bringing in like a Raspberry Pi and a cheap camera or something, okay? Okay? Other questions so far?
Am I right to assume that it sounds like the color of the floor is kind of irrelevant in this game then?
Not irrelevant, I guess, in terms of how the final score is defined. Not irrelevant in terms of helping your robot navigate, and we'll get to that a little more later today. Okay? All right, that was great. And now we have like 500 questions, but let me keep going because now I want to make sure I get through everything, and then we'll pause for questions again. Okay, we talked about the tournament, talked about the robots. Okay, code must run only on Arduino Uno. Again, must be fully autonomous, no remote control, no Bluetooth. Same rules as the homework and labs, so only registers, no pin mode, digital write, any of the Arduino libraries. With some very limited exceptions like serial print and analog read, which we haven't talked about yet because we won't have time to cover that with registers. Let's just give you a report, blah, blah, blah. Teams we talked about last time. This sign-up document is going to go live. I will literally publish it after lecture today as soon as I have a chance on my laptop. Again, pick your own team of 3. Last time we kind of talked about this last time, so I'll go through it fast. You can do a public ed discussion post if you're looking for someone. Private post if you want to be put on a team. I want you to sign up by this Thursday at 11:59 p.m. That gives me and the TAs Friday before break to pair any people we need to onto additional teams. And then when you come back from spring break, you'll be ready. And I think, given the number of students in the class, we should have exactly 45 teams of 3. And again, we kind of talked about last time, things to consider, schedules, different roles people want to do. I forget if I mentioned level of enthusiasm, right? You probably don't want to have widely disparate levels of like one person being like, I want to spend a ton of time on this and I really want to win the tournament, and another being like, I'm really busy and I kind of just do whatever I want to do, whatever I need to pass, but I don't want to spend a ton of time on this. That's probably going to create friction on the team. Something I got from other classes that have done group projects in the past. Have you ever done a team contract for any other classes yet? Okay, I see a bunch of head nodding. So same, I probably stole the template from somebody you've done it with before, but it has you lay out how you're going to communicate, what are reasonable expectations for turnaround time, when are you going to meet, what happens if someone violates the contract. I can't police all of that for you with 45 teams, but again, I think this helps lay out expectations in advance, and just be honest with each other, right? Like if there are 3 of you who are like, I'm really busy and I think I'm going to get a B in this class and I don't have a ton of time to sink into this project, and you want to be on a team and you agree on that, fine, by me, right? Like I'm not going to tell you how much effort you have to put into it. But again, you want to sort all that stuff out in advance and not find out 2 weeks later that it's not working, okay? Open lab schedule. Again, this is something I have mentioned before, and we were actually, I haven't scheduled this yet. We're going to do a poll everywhere in a minute. So after spring break, schedule changes. Rather than just the 2 lab sections per day, we are going to have either 3 or 4 lab sections per day. Okay, so you can sign up with a team from anybody who's currently in any section, and then your group will be able to sign up for either 3 or 4 lab sections per week. Okay, exact numbers to be determined. We do this just with a public Google sheet that has the time slots and the days and the lab bench numbers, so you just go in and put your group number and the net ID of one person in your group. Don't try to overwrite another group and steal their slot, because we can see the edit history for the spreadsheet. Okay, apparently this was a problem last year, but like literally all we have to do is just go file view history and be like, oh, this group tried to steal that group's slot. Great, you lose that now. Okay, so yeah, that should be like a really obvious that stupid don't do that thing, but just in case, saying it now. I am actually going to switch to poll everywhere now because we have done this differently depending on the year, so I want to get a general sense of what people prefer with no guarantee. So the first question is, would you prefer 3 2.5-hour lab slots per week or 4 2-hour slots? So this is the number of slots your team could sign up for. Okay, 3 2.5-hour slots, which would technically be 7.5 hours total, or 4 2-hour slots. So if you'd rather have kind of more flexibility for different times, basically this means the answer to this will probably determine whether we do 3 slots per day or 4 slots per day. Okay. If you'd rather have just 3, and you can, sorry, I should have clarified, pending first come, first served and availability on the spreadsheet, you can sign up for back-to-back slots on one day. So if you're like, we just want to crank through and do this for, 4 or 6 hours all on Wednesday afternoon or whatever, and that works for your group, and you get there for us to sign up for it, that's fine. If you're like, oh no, our schedules are really busy and mixed, we'd rather have more options on different days, maybe you want to do the 2-hour slot, or just let me know if you don't care. Okay, I'm going to close that in 10, 5, 4, 3, 2, 1. Okay, responses there. All right, I'm going to pull this over so you guys can see. Okay, pretty overwhelmingly for 4 by 2 hours. So again, no guarantees because this also depends on my TA availability, but I will certainly consider that when making the schedule. Okay, and then the next one of these, we need to figure out when they are going to be. So we're probably going to keep I forget the exact times for the 2 existing afternoon labs, so like 12:30 to 2:30 and 2:30 to 4:30 or whatever they are roughly. And then add either evening or nighttime slots. So I know there's kind of the 4:30 to 7:30 window where there aren't supposed to be any scheduled classes in case people have sports or extracurriculars. But some people can make it in that window and then have a club that meets later at night or something. And then the last time I did this, we had like a 9:45 to 11:45 section because the TAs and students were all okay with that. Like that is past my bedtime, but if it works for you guys. The results of this one might be a bit more of a moot point if we're leaning heavily towards 4 slots. Like I might just do 1 during that 4:30 to 7:30 window and then 1 later. But again, all of that depends on TA availability as well. So no guarantees based on the results of this poll. Let's try and just get that answer in quick, maybe like another 15 seconds. 10. If we don't care, just hit don't care. For some reason we had fewer responses to, there we go, now it's going up over 100. Okay, another 5, 4, 3, 2, 1, deactivates. Okay, let's look at the results of this one. Okay, so skewed after 8 p.m., but still a decent chunk for here. So tentatively, again, I need to check with the TAs. I think what we will do is keep the 2 afternoon slots that are already scheduled, and then just add 1 for each of these time slots. And that should, again, keep it in mind when you're forming your teams. Make sure you all have some overlapping availability. But that will try to optimize kind of doing what works the best for everybody. Okay. And then, as usual, I'm going to keep doing this until everybody gets the message and stops answering these from home. Don't answer this one. Keep it at 0. Okay. No, somebody did. I really can't tell if this is someone doing it from home or somebody in this room just totally not paying attention. and like mindlessly staring at poll everywhere and answering the questions for some reason. Okay, it's only at 1, no, 2, 1. See, that I don't get. Like, are you in here? Now you're just messing with me? Somebody answering it that's just toggling between 1 and 2. Okay, I'm gonna put, it's at 1, no, 2. Okay, whatever. 5, 4, if the person who's messing around is still there when I hit deactivate, then you're just in trouble. 3, 2, 1, deactivate. Okay, great. Thank you. All right, let's go back to the PowerPoints. So, all right, did the polls. I will be posting that schedule, and the spreadsheet will be available. So when you come back from spring break, the sign-up slots will be there. Working on the project, some more stuff about kind of keeping things even. Again, this has historically been kind of a rule from the lab staff and the department, not just me. So you can't, I mean, you can get mad at me for this, but I'm not the one who made up these rules. Basically, you can work in the Mechatronics lab and you can work at home. You cannot work on this project in project team spaces, okay, or other labs that you're doing research in or anything, because this creates unfair distribution of resources, right? If you are doing research in a professor's lab and you have access to a lab bench there and an oscilloscope that you can go use whenever you want, and there's another team that doesn't and they can only get access to an oscilloscope in the Mechatronics lab, okay, it's not fair for you to have 24/7 access to that resource, okay? Same goes for project team, any other restricted access space, okay? You're welcome to take your robot home to work on it. The advantage of working in the Mechatronics lab is we are going to have the practice boards and the cubes, right? So you don't have that at home, but just for kind of the basics of getting your robot to drive around, you can do that on the floor of a dorm room or apartment or whatever, okay? The other place you cannot work, any public spaces like lounges and classrooms, okay? This has historically been because the janitorial staff wind up having to clean up resistors and bits of wire everywhere and stuff. Just kind of a project that takes up a lot of space, can be loud, noisy, distract other students. So you will get in trouble if you do this, okay? One of the TAs tells me, hey, I saw this team working on their robot in the project team space, right? There will be, either you get banned from the competition or there is a penalty on your final project grade, okay? Not messing around with this one, we are keeping it even for all teams. We have a smaller than usual class this year. There's only 135 of you. Last year was almost 180, so there should not be an issue with access to the Mechatronics lab, okay? That should be plenty for what you need to get this done. Okay, in the last 10 minutes, we're gonna try and get through the milestones. So basically to prevent you from procrastinating this until the last weekend before the competition, there are weekly-ish checkpoints to demonstrate that you are making progress with your robot design. So I'm gonna skip through this slide and just kind of talk about them in more detail. You cannot use homework slip days for these, okay? So these are a separate thing, part of the project. They have a deadline. I talked at the beginning of the semester about how, you know, ideally your job has some day-to-day flexibility, but then some things have real deadlines. Okay, these are the real deadlines. You are welcome to finish them early. Finishing them early is actually used for seeding in the tournament, so that if you really want to go gung-ho and win this thing, the earlier you complete your milestones, the higher you get seeded in the tournament. If you say, screw it, I'm busy, we're going to submit them right before the deadline, again, that's fine, but you're going to be seated lower in the tournament, okay? All the details and deadlines for these things are on Canvas. The first milestone is basically just proving to us that your robot can steer, okay? We're asking you to show us that it can drive forward and backward and turn left and right. This is just hard-coded, open loop, no sensor input. It does not have to be perfect 90-degree turns or perfectly 1 foot, whatever the dimensions are, that's all on Canvas. But basically by the end of the first week or two, we want you to show us that you have a robot that can actually drive around, right? If your robot can't even drive by week 3, you're kind of starting to fall behind. You're also going to have to give a design pitch. So this is called a milestone, although it's kind of different from the other ones that are physical things with the robot. This is kind of a short, informal presentation to the TAs, making sure you have kind of a strategy and a mechanical design in mind for your robot. Details and rubric for that will all be on Canvas. Milestone 3, demonstrating that you can do color and border detection. So there's a kind of test board where you will start out on one color, drive to the other color, turn around and come back without driving off the border. We're going to talk more about those sensors. So now there's sensor feedback, kind of controlling how your robot's driving. We're going to talk more about that after spring break. Milestone 4 is basically doing the competition without the enemy robot. So starting on one side of the board and gathering as many cubes as you can. This goes to a couple questions from earlier. So one was starting position. Your robot will always start touching the black border centered on one side of the board, but you can choose the orientation. Okay, so the side you start on will be random. You may start in yellow or blue, but you can decide if you want to start facing forward, facing the side, at an angle, and that, again, there's no right or wrong answer. It's probably going to play into your robot strategy, right? You could say, I want to start facing to the left, kind of follow the border, and then try and sweep cubes this way. Or you could say, I just want to make a mad dash for the center, right? Grab as many cubes as I can going forward, and then do something from there. And then regarding the border between yellow and blue, basically the cubes are going to start close to this border, within kind of the middle third of the board. So even though it doesn't matter where you wind up, knowing where this border is going to be useful when it comes to trying to get the cubes. Okay? And again, we're going to talk a lot more about the sensors that help you do that after spring break. All right. Navigation and sensing and kind of a high level overview. Again, we're going to get more into how the sensors actually do this in a couple weeks. You choose how many sensors to use and where to put them. There are going to be different sensors available to you. You need to use some to accomplish the milestones. Some are optional. So one, we have a sonar sensor or ultrasonic distance sensor. This emits bursts of ultrasonic sound, measures how long they take to reflect back, so you can use that to measure the distance to an object in front of you. It is not perfect. It is not LiDAR or kind of like self-driving car stuff. Reading it gets depends on the shape of the object, the texture of the object, how well it reflects sound. The cubes are pretty small, so it's probably not going to do a great job individually detecting the cubes. It can probably do a reasonable job detecting the other robot. So whether you choose to use that one is up to you. It is not required for a milestone. If you want to design your robot to react if the other robot is in front of it, say, okay, I'm going to avoid it, or like, damn the torpedoes, I'm going to crash into it, or something in between, up to you. There's something called a QTI sensor, which again we'll talk about after spring break, which is useful for detecting the black border. There are color sensors that can detect blue versus yellow, and then you can purchase other sensors if you want. So again, if we think about this competition board, this little PowerPoint diagram kind of represents something with two of these line sensors and one color sensor on the front. Then I could say use these sensors to follow an edge. Say this one sees black, this one doesn't, so I know my right side is on border. I can use that to follow an edge. I could use the color sensor to detect, okay, I'm on the border between blue and yellow. If you're just kind of in the middle of a color like that, you don't really know anything until you hit an edge. And again, going back to the Raspberry Pi question, there's no computer vision here, right? You do not have an overhead camera that gives you the exact position and orientation of your robot. You don't have a camera on the robot mapping out what you see in front of it. You have fairly limited sensor information that can kind of tell you your state about roughly where you are on this board. And if you're tracking that, maybe you remember what your last state was. Okay, like where was I where was I previously and where am I now? And you can use that to figure out kind of roughly your position and orientation on this board, along with other things like, okay, is the other robot in front of me or not? Okay, but that is an extremely open-ended problem. If you're interested in this sort of navigation thing, go take autonomous mobile robots after this. That's kind of a popular follow-up elective. But for this class, we're basically setting you up with the sensor information, and then you decide what you're going to do with it. Okay? When you guys took a programming class, did you learn about flowcharts? Okay, see some head nodding. Part of your design pitch, we're going to ask you to kind of have a rough flowchart for what your strategy is. So representing, okay, we're going to start, we're going to drive forward. If we see the other robot, we're going to do this. If we see the border, we're going to do that. Not going to spend a ton of time on this. We just want you to have kind of some algorithm or strategy thought out. There will be a final report. So in addition to the tournament, there is no final exam for this class. There is a final report kind of documenting your robot, so the code, circuit diagram, strategy, mechanical design, and all that stuff. So don't worry about that yet. I need to double check the rubric. That will all be on Canvas. New this year, the MAE department has decided that it wants all students to build an online portfolio as they go through the program, because this is a really useful thing to have in addition to your resume. They want to pilot this class as part of that portfolio. So basically what this means is you have to write the final report anyway, but there will be an online, I don't know, I think they might use GitHub. I don't know exactly what the website or system is going to be yet, but even though this is a group project, you will each be kind of taking the group report and then maybe customizing it or tweaking it to say what specifically you worked on and making that part of your portfolio. I need to check with Professor Guy Hoffman because he is in charge of organizing this. The current plan for now is to have that be optional extra credit, so something like 5 points out of 100 on the final project. Obviously, to keep things fair, it is also open to non-MAE students, so it's not like I can only give extra credit opportunity to the Mechis and not everybody else. So that is something where I believe if you want to use the portfolio, even if you're one of the BME students or something, you can still have access to that system, or if you're like, whatever, I just did that once to get the extra credit in Mechatronics and I'm never going to touch it again, that's fine too. But more details about that will be forthcoming as well. Okay, so I'm going to finish this here and then we got a couple more minutes, actually, pause. 3 minutes for questions, and then real quick before you go, I'll kind of do the recap, what to do before you leave here today. Other questions? Yes?
Are we allowed to use different programs between matches?
Are you allowed to use different programs between matches? Good question, I forgot to cover that here. No. There is a check-in in the morning, so you will come to lab, the TAs will watch you upload your code to verify that it does not have Arduino libraries in it, and then they will take your USB cable. Okay, so there is no re-uploading code. That is not to say you couldn't write a program with a random number generator at the beginning and 3 different strategies, right? That may be overkill, because since none of the other teams can change their programs either, right? It's not like they're going to watch your robot and change their strategy when they know they're up against you. But if you wanted to run different programs, that is how you could do it, I guess. Otherwise, it has to be the same program. There's no re-uploaded code. Okay? Yes?
Could you use a sensor input when you first initialize to make it branch a different way? Like when I press on the robot, if it sees something here, it does a different path?
Yeah, absolutely. Because you're not. So the question was, can you use, and you might do that with. This mattered more when it depended what side of their board you were on, but the color sensor is a good example, right? If the goal was to start on blue and bring the cubes back to blue, versus start on yellow and bring the cubes back to yellow, you would be taking that initial reading. So anything is fine as long as you are not. I guess another thing, no toggle switch to switch between different programs, right? In theory, you could also have 2 different programs and select between them with a toggle switch. That algorithm, it needs to be autonomous after you power it on, right? So there's no initial set through a manually flipped switch. I think I saw a hand way in the back there.
Yeah, will CAD models be made available for the OEM components or the
I'm pretty sure we have CAD models for the robot chassis. I don't know if they're available for the individual sensors and things, but I will check with Dave Martino about what's available. Okay? Okay.
If our group decides that a simple design is the best design, would we get points taken off for having like a simple?
Nope. Simple. Again, the example from 2018 is a perfect example of how complicated is not necessarily better. The rubric and everything will be on Canvas, but there are no bonus points for creativity or complexity. Okay, so simple, and that's not to say that simple is going to win this year. I haven't run it with these rules yet, so I don't know. Okay, one more question up here, and then I want to go through this real quick, and then we'll go, okay? Is there a weight limit? I need to double check the rules. No hard weight limit, but in practice, you are limited by your budget. Again, like maybe rocks are cheap enough that you could pile on 20 pounds of rocks, but then you're going to hit a budget limit with motors that are powerful enough to move those rocks. Okay, real quick, when you leave here, I will be publishing everything right after class. Read the team contract and the rules before you form teams. I realize that like half of you will ignore me and you already know who you want to work with and we'll just jump to step 3 anyway. But like, again, don't want this project to ruin any friendships. Please just double check your kind of schedule, enthusiasm level, different things you want to do. Then form teams. I will be publishing the spreadsheet in like 30 seconds. Okay? Thank you.